Good morning, all. This century has seen a rapid evolution in the field of technology. One such advancement is in the field of nanotechnology as an extension, the field of composites. Today, let us discuss about the smart composites that find its application in civil engineering field. So, this is a tech talk on smart composites which are increasingly used in the field of civil engineering. I am Sukanya, Assistant Professor in Civil Engineering Department, Vedavyasa Institute of Technology. So what is smart composite? A material which has two or more components with varying physical as well as chemical properties is referred to as smart composites. These composites are mainly composed of two components, which are the matrix and the filler. So what is the matrix and the filler? The matrix is a base material that provides enough strength, stiffness and bonding to the other components. Matrix could also be called as a binding component. The next component is the filler. The filler are reinforced onto the matrix to improve the properties of the composites. The properties are flexibility, strength, durability, etc. By combining both the many smart materials, this can lead to evolution of characteristics which were originally absent in the parent components. By merging different components, the properties such as magnetic, optical, fire resistance, anti-corrosive properties of the composites may be obtained. Combining the matrix and the fillers yield different types of composites. Based on this, the composites may be classified as follows: carbon-based composites, polymer-based composites, metal composites, ceramic composites and nano-composites. Out of these, the nano-composites have found larger popularity in the last few decades, and this is due to their chemical as well as physical characteristics, which are huge surface area, flexible synthesis methods, etc. By combining the various characteristics, that is superior mechanical properties of high modulus and strength, along with other attributes of lightweight, this has led to the formation of smart composites. The construction sector and the civil engineering sector have started recognizing the importance of these composites of strengthening materials or smart composites for constructional applications as well as for preserving the damaged infrastructures. The last few years have witnessed increased use of fiber reinforced polymer composites due to their excellent properties. So this provides a brief about the various applications of composite materials in the civil engineering field. As you can see, the composite materials may be used in sensors, road construction, steel industry, restoration and rehabilitation, concrete manufacture in glass industries, aerospace and automotive manufacturers, building construction, etc. Not only these, it finds a variety of applications in other sectors as well. So, the applications of composite materials in civil engineering field is unlimited. Materials have been used by civil engineers for various purposes which range from sensors to megastructures. In case of megastructures, the property of lightweightiness is an added advantage when compared to conventional materials. The table below gives the various composites which are used for civil engineering applications. The composites which are mainly used for civil engineering applications are bitumen or polyethylene terephthalate or HDP. HDPE stands for high density polyethylene. Yet another material is concrete or FRPC. FRPC stands for Fiber Reinforced Polymer Concrete. Another material is gypsum, asphalt, cement or polyvinyl alcohol fibers, cement or carboxyl carbon nanotubes. So the metric as well as the filler of each of these composites are given in the table, and what are the contributions in civil engineering field is also given. So combining these composites onto concrete, the properties or functionalities of concrete structures could be enhanced, and this leads to a variety of applications in the civil engineering industry. So first, let us talk on to smart concrete. Concrete, as we all know, is a hard, inert structural material which is widely used for construction. It consists of aggregates which are bonded by cement and water. By aggregate, I refer to coarse aggregate as well as fine aggregates. So this concrete is a heterogeneous material which consists of crystalline structures of various structures. By incorporating nanotechnology into concrete, this has offered an effective solution to the situation related to the composition of concrete mixture. Incorporating nanomaterials like nanorods, nanoparticles, carbon-based nanostructures, etc. have improved the properties of concrete and also improved the structural integrity of buildings and other constructions as a whole. Nanoparticles such as nanoclay, which is shown in the figure, nanoalumina and nanoiron, which is also shown in the figure, etc. are also incorporated into concrete to improve the properties of concrete and formation of CSH, that is calcium silicate hydrate gel. So calcium hydrate silicate is formed in the initial stage of hydration of cement. As the cement starts setting, CSH or calcium silicate hydrate starts densifying. Introduction of nanoparticles improves the physical as well as mechanical attributes of the concrete. As nanosilicon or nanosilica is incorporated into concrete, it improves the segregation resistance, which otherwise is a major disadvantage in concrete structures. This also improves the mechanical strength of stiffened concrete than the conventional concrete. It even provides higher water repulsion characteristics, and it also prevents calcium leaching. Natural fibers may also be added into concrete, and this has proven to enhance the mechanical as well as physical characteristics of concrete when compared to the conventional composites used in cement. Coal derivatives are also being increasingly used as reinforcement in concrete mixtures, and this is used for construction applications as well. So, not only nanofibers but also coal derivatives could also be used as smart composites. Yet another material is bottom ash, abbreviated as BA. This contains coarse granular particles, and it serves as a substitute to conventional cement and sand in bitumen, and also replaces the fine aggregates for making concrete structures as well as mixtures. The fibers in composites have many advantages, which are it is cheap, eco-friendly, and is also biodegradable. The composites which are used as smart composites tend to be low weight, and this have proven to have several merits such as durability, mechanical strength, low expansion, ease of usage, thermal as well as acoustical properties in building constructions. The composites which are used for smart composites are relatively less expensive compared to conventional concrete. We all know that concrete is a material which has increased the carbon emissions to the environment, and it is said to be about the fourth largest carbon emitter to the environment. Using smart composites has reduced carbon dioxide emissions, and also it has improved the conservation of energy as well. Road construction. Road accidents have been alarmingly increasing in the last few years. Accidents in roads are mainly caused due to potholes, speed breakers, and bad road conditions. Cracks and other problems are generally caused due to substandard materials which are used for construction of pavements. The stress of pavements is generally caused due to the viscoelastic characteristics of bitumen. The bitumen is a material which is increasingly used for road construction, and it is supposed to offer the flexibility, workability against extreme weather and massive load conditions. But this does not occur because as the age of bitumen progresses, the bitumen is subject to hot weather conditions and rapidly deteriorates. Immediate replacement of the bitumen with an advanced version like smart composites has become a major necessity, as only then the life as well as the functionality of the bitumen will be satisfactory at elevated temperatures. The composite bitumen or magnetite act as a potential material for road construction. This material have magnetic self-healing nature even after the application of heat. The most commonly used polymers for bitumen are styrene butastyrene, abbreviated as SBS, which is a copolymer that improves the stiffness of bitumen. Also, ethylene butyl acrylate provides protection against rutting, and styrene ethylene or butylene styrene provides resistivity to heat. So, using these polymers enhances the property for using it for road construction than the conventional bitumen. Other materials which may be used are carbon nanotubes, silicon dioxide, titanium dioxide, styrene butane styrene, rubber, ethylene vinyl acetate, municipal waste and biomass. Hence, the pollution caused due to the municipal waste could also be reduced, and at the same time the property of the bitumen could also be enhanced and used for road construction. So the figure shows road construction using modified bitumen. So as you can see, it offers good aesthetics along with improved strength. The composite bitumen, which is synthesized from elastomers, have proved to improve the stiffness as well as have shown to extend protection from damage by increasing viscosity. Styrene butane styrene elastomer is known for enhancing the viscoelastic properties of the pavement even at high temperature. This is done by improving the stiffness and protecting against damage. Another material which is nanoclay, which when used along with bitumen or polymer matrix has shown to improve the storage stability of material along with increasing the resistance towards aging. Nanosilica modified bitumen, another material, has shown to have exhibiting good absorption, chemical purity, dispersion ability, stability, and offers a larger surface area. So, in total, 6% weight when it is used in nano bitumen mixture, the composition of nanosilica is considered as an optimum value. So, even by using smaller quantities of nanosilica, smart composites, the properties of bitumen mixture can be enhanced and used for road construction. Next is application in case of sensors. So, why is sensor used in civil engineering applications? Civil engineering structures may be prone to damages as well as faults. These need to be determined effectively. So, the process of monitoring and the detection of fault as well as damage in civil engineering structures is generally termed as structural health monitoring, abbreviated as SHM. So, structural health monitoring is very important as far as the civil engineering industry is concerned. These systems are very much important in major structures like dams, nuclear power plants, skyscrapers, bridges, etc. These are large structures and the failure of these structures would lead to major disasters. So, the health monitoring of these structural systems are very much necessary. If a damage occurs in a building, it is monitored and then analyzed using special softwares. This is shown in the figure at the top. The safety of the damage that has occurred is estimated systematically, and thus it eliminates human interference and gives accurate results. So after the analysis, the damage is determined as safe, or alert is also announced if it is not safe. A practical and an active sensor system detects various properties that strains, defect and temperature, and thus ensure the safety and prolonged lifespan. How is the sensing done in civil engineering is, it is based on the detection of electrical resistivity. So, if composites are incorporated along with concrete, it forms a matrix and thus offers a resistivity to the passage of electricity. And by the piezo-resistivity principle, the sensing property is improved in structural health monitoring and thus helps to determine if the damage is safe or not in a system. ISSC, or intrinsic self-sensing concrete, is an example of structural health monitoring system, and it is manufactured by embedding functional fillers into the concrete matrix. This has a potential to detect various parameters in the concrete, that is stress, strain, cracks. By detecting these following parameters, the damage as well as durability and mechanical attributes of the structure can be determined as a whole. The fillers which we used are functional and tend to form a conducting network within the concrete composite. By applying this mechanism, the damage in roads, buildings, dams, etc. can be detected by studying the piezo-resistivity or the electrical behavior of these composites. What are the various materials used for structural health monitoring? The materials used are carbon nanotubes, carbon nanofibers, continuous and short carbon fibers, which are nanomaterials. ESF, which is used as reinforcement in cement mixture, has shown to have improved the functionality and the mechanical performance of cementitious materials. Carbon nanotubes and carbon nanofibers are increasingly used as fillers, and this create self-sensing materials, and these materials have shown to have exhibiting excellent mechanical as well as thermal and electrical properties. Carbon nanofibers and carbon nanotubes filled composites are able to sense the micro as well as nanoscale defects and damages in civil engineering structures. So, these are highly efficient as India is famous for its historical monuments. The environmental conditions in present days have led to deterioration of architectural beauty as well as structural strength of these monuments. Some methods have been devised to enhance the strength as well as the aesthetic of these buildings. The plastering of architectural masonry buildings is mainly done using cement lime mortar or simply lime mortar, and it is designed with architectural components with materials like natural stone or artificial stone having lime as well as cement content in them. But the countries which lie on the median or the northern hemisphere are subjected to fast deterioration due to the freeze and thaw cycle and the elevation of moisture content. Even if restoration is done to these monuments, the front architectural pieces may be deteriorated even within some years. So, instead of using the conventional methods, some advanced materials are required so that the materials which are used for the repair and rehabilitation of historical monuments are fiber reinforced concrete and high performance concrete. These are some of the findings in nanoscience field, and in both of these HPCs or high performance concrete have properties like high mechanical strength, excellent technological characteristics, good durability, etc. They also have architectural applications, and it offers an ideal surface for decorative elements as well. So, using of HPC in historical monuments improves the aesthetics along with providing stability as well as durability to these structures. As commonly known, high performance concrete is formed by lowering the water cement ratio, and thus it forms a denser microstructural package, and hence it improves the impermeability of concrete and also improves the mechanical strength. The use of steel fibers have shown to have created rusting sites on the surface, and for this plastic fibers have been used instead of steel fibers. This have added to strength of bridge walls, columns, girders, and these are also used for cable bridges as well as bridge decks. Other material than fiber reinforced concrete and high performance concrete is timber concrete composite. These concrete composites were used for floorings, and it was used for the repairing of historical monuments in Europe. These have been utilized for refabrication of old timber floorings. So, coming on to the conclusions, as seen from these slides, the composite materials, that is smart composites, play an important role in designing civil engineering structures as well as its rehabilitation. The use of nanomaterials, fibers and relevant fillers have been used to improve the properties of concrete such as mechanical, erosion, thermal, rheological and barrier properties. From the applications listed of the smart composite, it is evident that the applications of composite material for concrete, constructional applications, rehabilitation, sensing, etc. in the areas of civil engineering are unlimited. These are the references. Thank you.